We are students of the Energy Engineering major at Universidad Politécnica de Cuautitlán Izcalli, which in presentation will talk about heat storage. Okay, what is storage? Before fully clarifying the meaning of the term storage, it is interesting to understand its etymological origin in this which we can determine that it comes from a river word. Storage is referred you as a store resource procedures. This operation is related to the collection, storage, archiving, or recording of something. What is the heat? It is a type of energy generated by molecular vibration which causes temperature increase, expansion of objects, melting of solids, and evaporation of liquids. In general, it is increase in temperature of the environment or body. It consists of the transfer of fraction of thermal energy from one entity to another. It can be transferred between elements using mechanisms such as convection, conduction, and radiation. There are three types. The one is specific heat, the amount of heat that needs to be stored to unit mass of substance to increase the temperature by 1 unit. The second is latent heat, is the amount of heat transferred to a unit mass of substance to change its state. And finally is sensible heat, is the amount of heat absorbed or released by body without it change its physical state. But what is the heat storage? Heat storage, as the name implies, is used for future use but just to store it in a material for a period of time. This is achieved by heating a material, then can store heat inside and it needs to return to the environment for cooling. The process occurs and the reverse. It's the process takes place, the heat is taken away from the material, then cut so that it and can absorb more heat.
Heat transfer. It occurs when two systems with different temperatures come into contact. The process persists until thermal equilibrium is reached, equalizing the temperatures. When there is a temperature difference between two objects or regions close enough, it cannot be stopped, it can only be encouraged. Next, please. Conduction. It is the result of the interaction of molecules. In general terms, the transfer by conduction will occur from a region of higher temperature to a region of lower temperature, being a transfer with the temperature differential. Within the solids, there are two general categories. The first one are the metals. They are good conductors of heat because they have many electrons that can move freely. And the other category are the nonmetals. These have a small number of free electrons, positioning them as poor conductors of heat. In addition, these also depend on the type of the phase in which they are. For example, gases are very poor thermal conductors, since their molecules are far apart and can generate frequent collisions, unlike liquids and solids that are good conductors because their molecules are closer together and their interaction is greater. Fourier laws is used to quantify conduction and states that the rate at which flow is transferred by conduction is proportional to the temperature gradient and the cross-sectional area in the direction of flow. The K is the thermal conductivity of the material, and the minus sign is the consequence of the second law of thermodynamics, requiring that heat flows from a region of higher to lower temperature. Next, please. Convection. This type of transfer depends on two mechanisms. The first one is the due to molecular motion, taking the same principle as conduction, and the other is due to macroscopic motion of fluid packets. This movement is a result of fluid packages, each with a certain number of molecules with movement in relation to the external force, which depends on a density gradient in natural convection or by the pressure difference of a pump or fan. This type of transfer depends on density, viscosity, fluid velocity, thermal properties, in this case the specific heat, and the thermal conductivity. Taking a basic examples, we have the air and hot water heating system, the cooling system of a combustion engine, and the body's blood flow. There are two other factors involved in convection. The first one is the forced convection. The flow is due to a differential of densities due to the thermal expansion. And the other is the natural convection, the rise of hot air. Next, please. And finally, we have the radiation. This is attributed to change in an electronic configuration of constituent atoms or molecules. In the absence of medium, there are a transfer by radiation between two surfaces at different temperatures, because every surface emits energy in form of electromagnetic waves. This can occur by visible light, infrared, ultraviolet radiation. The radiation rate of surface energy is proportional to its surface area, which will increase rapidly with the temperature. The heat flux for bodies with a given high heat is defined as the formula that you can watch, where the emissivity of the material is dimensionless between 0 and 1, representing the radiation rate of a given surface. A is the area. The sigma is the fundamental physical constant called Stefan constant. A body that emits radiation at a certain temperature is the T. Also absorbs radiation from the surrounding at temperature is the T for T red for. Next, please.
Now we are going to talk about the philosophy. The first is sensible heat. It's the type of energy that the body or any object receives, which generates a change in this temperature, increasing without actually inferring its molecular structure and state. Now, I'll explain the formula where Q represents the heat and energy transfer between the system. M is the mass of the system, and the actual temperature is the relation to which is the higher the specific heat of a substance versus a certain heat, so the less its temperature will vary. For example, we prefer to use one spoon for cooking and not the aluminum. One, since the specific heat of food is considerably higher than that of aluminum. Well, now we are going to explain a little examples. For example, heat water from 0 to 100 Celsius degrees and put a spoon in a hot water. The spoon will heat up, food will not change its solid state. And the second is latent heat. It's about the energy that is needed to change the phase of certain amount of substance, be it from solid to liquid, heat of fusion, or from liquid to gaseous, heat of evaporation. And as we can see now, the formula is Q, it is M plus L. Now, where Q is amount of heat, M is the mass, L is the latent heat. In the international system, latent heat is given in joule per kilogram, but it can also be measured in calories per gram. Note that the latent heat can have negative or positive values. Therefore, if the system is given its value will be negative, but in this case it's the exothermic process or in another liquefaction. Next, please. Now, talking about the latent heat of fusion, this type of heat is the energy taken by substance when they altering their condition when changing from gaseous to liquid and from liquid to solid. The same amount in refrigerations. Next, no. Now, latent heat of evaporation, it consists of the amount of energy to which it's necessary to expose a gram to fluid to compare it to a gaseous state. This term is different from the boiling point at which temperature is described. So when talking about the heat of evaporation, an amount of energy is described. And the specific latent heat of solidification, the amount of next, please. Now, talking about the specific heat, this refers to amount of heat that is required to increase the temperature of the unit mass of a certain component or element by 1 degree. This energy comes from the transformation of other energies, where it organized from the vibratory movement of the molecules and atoms that make up the bodies. And molar specific heat is described as the amount of energy required to increase the temperature of 1 mole of a complement by 1 degree. Similar heat has energy supplies can be divided into 3 transfer structures. And finally, dry heat is the thermal sterilization technique where its effect is equivalent to breaking in microorganisms. Next, please.
Well, talk about this heat storage system. We need to know that there are 3 forms to heat storage, and this depends of the type of the heat. For example, the sensitive heat is the storage is based in increase or decrease in the temperature of the medium. The CHTES systems that currently being developed are as follows. For example, tanks with liquid. These are systems of simple operation. They have a tank with fluid that is heated by solar radiation or another process that rejects heat. Other is the molten salts, and the other is bedrooms. And latent heat storage. This storage is based on the heat absorbed or relate with material undergoes a phase change from a physical state to another. For example, liquid as solid, solid, and liquid to gas. These change materials are latent heat storage materials. It is possible to find materials with a latent heat of fusion or melting temperatures within the same range. To be used to design the thermal storage, we using most archival desirable thermophysical, kinetic, and chemical properties. They are classified into organic compounds, inorganic compounds, and euteric alloys. They can be quiescence, acids, alcohols, salts, metals, these materials. And the other is the thermochemical storage. This storage is based on the use of the energy source to introduce the reversible chemical reaction or sorption process. And this reaction is a sorption reaction. Also, the thermochemical storage can be classified into chemical reaction or sorption process. The chemical reaction is characteristic by change of the chemical bonds of the compound involved in the reaction. The energy can be stored through the endothermic reaction and relayed by the reserve exothermic reaction. Sorption storage is defined as a phenomenon of fixation or capture of gas or a vapor by a sorbent substance. Next, please. Each of these storage have advantage and disadvantage. For example, in the sensitive heat storage, the one advantage is that it is less complicated compared to the other storage. And one disadvantage is that it is currently less efficient for heat storage. In the latent heat storage, one advantage is that a high storage density and the isothermic nature of the storage process. And what disadvantage is that it's expensive and often complicated to produce. In the thermothermical storage, one advantage is that they have a high energy density, and what disadvantage is not easy to type of receive reaction and they can we use efficiency. Next, please. Heat storage application. It is capable of storing large amounts of energy at relatively low cost, and its section as device as heating and cooling of homes and buildings, in industrial heating or cooling process, and even as a complement to massive energy storage for the electricity grid. They can also be used to balance energy demand during the day and the night, and the heat result must be maintained at a temperature higher or lower than the ambient temperature. Next, please. New technologies. An European project aimed at investigation the application of the steel mill glass of a storage material with the recovery application with the steel mill itself. A study of the behavior of the glass to be used as a material for thermal storage in the solar thermal power plant. Both in the new generations and in the traction ones, and solutions to recover heat from the slag itself, improving which and preset it is what. Next, please. Well, this is all for us. Thanks for watching.